Namaskar. Today we will discuss about the Indian clinometer and basic principles of land surveying. Introduction. Clinometer is an instrument for measuring angles of slope or a tilt, elevation or depression of an object with respect to gravity. It is also known as tilt meter or tilt indicator, slope alert, slope gauge, gradient meter, gradiometer, level gauge, level meter, declinometer and pitch and roll indicator. Clinometer measures both inclines, that is positive slopes as seen by an observer looking upwards, and declines, that is negative slopes as seen by an observer looking downwards, using a 3 different units of measures: degree, percent and topo. Astrolabes are inclinometers that were used for navigation and locating astronomical objects. Surveying has been important since the beginning of civilization. Today, the importance of measuring and monitoring our environments becoming increasingly critical as our population expands, land values appreciates, our natural resources dwindle and human activities continue to pollute our land, water and air. As a result, the breadth and diversity of practice of surveying as well as its importance in modern civilization is increasing from time to time. Surveying is indispensable to the engineer when planning, designing and constructing a project. So, all engineers should have a thorough understanding of the limits of accuracy possible in the construction and manufacturing processes. This knowledge, combined with an equal understanding of the limits of and capabilities of surveying, instrumentations and techniques, will enable the engineer to complete the project successfully in the most economical manner and in the shortest possible time. Types of clinometers. The Abney level clinometer. The Abney level, like other clinometer, gives the angle between the horizontal and sloping lines. It consists essentially of a telescope T to which a protractor P is rigidly fixed. The middle point of the protractor is marked by a 0, and on both sides the 0 or the graduations ranging from 0 degree to 60 degrees. Liquid capacitive clinometer. Liquid capacitive clinometer, whose sensing elements are made with liquid capacitive technology, they are considered gravity based. The best way to understand how they work is to think of a disc like cavity that is half filled with dielectric liquids. One of the sides of the cavity has an etched conductor plate that is used to form one of the conductor of a variable parallel plate capacitors. The liquid along with the other side of the cavity forms the other plate of the capacitor. In operation, the sensor is mounted so that the disc is in a vertical plane, that means with its axis horizontal. Gravity then acts on the liquid, pulling it down in the cavity, forming a semicircle. As the sensor is rotated, the liquid remains in this semicircular pattern, covering a different area of the etched plate. This change in the area results in a change in the capacitance. The change in the capacitance is then electronically converted into an output signal that is linear with respect to the input angle. Indian clinometer. This clinometer was developed by the Survey of India, hence its name. It is also known as the tangent clinometer. It is always used along with a plane table. The Indian clinometer consists of a plate of brass and 2 flaps at the end of the plate. The flaps stand perpendicular to the long plate of brass. The plate has a bubble and a leveling screw by means of which the bubble can be brought to the center of its run and the instrument is leveled. One of the 2 upright flaps has a sighting hole where the observer places his eye when sighting the object. The other flap has a long slit and is graduated along both edges. One edge bears the trigonometric tangents and the other is degree of slopes, but at the middle there is a common 0, so that the 0 and the sighting hole are in the same horizontal alignment. Procedure: the surveyor goes into the field taking with him a map which is already drawn. His purpose is to find out the heights of vertical objects. He sets the plane table at some points and resets his position. The clinometer is placed up on the plane table. The first thing will be to find out the height of the point where the table is placed. Therefore, a point of known height is first sighted and the height of the resected point where the table is fixed is thereby determined. Thereupon, other points are sighted and their heights are also determined. By means of the Indian clinometer, a ratio between the vertical height and the horizontal distance is calculated. Factors which influence the use of clinometer: overall accuracy varies depending on the type of clinometer and technology is utilized. Gravity, temperature, that is drift or zero offset, linearity, vibration, shock, cross-axis sensitivity, acceleration and deceleration. A clear line of sight between the user and the measured point is needed. A well-defined object is required to obtain the maximum precision. The angle of measurement precision and accuracy is limited to slightly better than 1 degree of arc. The clinometer is also commonly used by foresters to obtain the percent slope of terrain. This measurement is based on the same trigonometric principles described above. Slope measurements, however, require that both observer and the target to be constant height above the ground. Thus, a range pole or height of measurement h stick is often used in slope.